Good morning. Can you all hear me? I think it's pretty loud. So welcome. Thank you for joining me in this session. Uh, let's see. So I'm Sandeep Chandra. I work for San Diego Supercomputer Center. That's located in beautiful Southern California. San Diego Supercomputer Center is part of UC San Diego, which is one of the premier academic institutions over in California. It's part of the big UC system. SDSC, which is my organization, has a long history in high-performance computing and data management. But over the years, we've expanded into other areas like working in healthcare, big data, a lot of that, data science, those kind of efforts. So I'm here to talk about a few things that my group works on, and hopefully some interesting things for you to take away. Just very quick, I'll give you a little background and context, set things up, and then we'll dive into some specific things. Just for my benefit, a show of hands of people here who are in cloud operations, just so that I have an understanding of people in cybersecurity and big data applications. Okay, well, so clearly that's a lot more. I think the talk really focuses a lot on the architecture we've built from a compliance and security standpoint in the cloud to run a big data platform. So it's more platform and cybersecurity centric, because that's really our core expertise here. And we've gotten into big data as a result of organization moving into it, and some of our customers who've brought in this technology to us. And so really that's how we've gotten in. Just to set up a context, University of California, that's what we are part of, UC San Diego. It's, if you thought about UC system, it's really like a Fortune 500 company if it was a profit company. So it's really big in terms of numbers, total annual budget, what it contributes towards California as economy, which is one of the bigger economies in the world. In terms of what faculty we have, it's 10 different universities, 5 medical centers, 3 national labs that are part of this UC system. A lot of research goes on, a lot of patients being managed at these hospitals. So really it just shows you the scale and the growth of UC system and all the data that they manage and the kind of things they deal with. So a few years back, there is this group called the UC Risk Services. They are located in the UC's headquarters in Oakland in the Office of President, and they had this charter where they were collaborating with the UC health system, which is the 5 medical centers. And they basically had to build a consolidated data management platform that could process data from multiple systems. And really the focus behind was, how do we get data on incidents that happen in various hospitals and patient experience feedback and really report on this data so they could improve on those things. And then over time, they envisioned that this data would grow to have other things like claims, settlements, student health information. And the risk services group within UC, their job is to manage risks, make sure that they are not in lawsuits, that they are trying to manage all of this data and using it in the right way to really safeguard the risks for the university. So really the system they built was the risk services data management system, was a system-wide integrated view of all this data coming in from the various environments. So that really was the key behind this collaborative effort. Cybersecurity was a big priority for them. A lot of you here may not know, but a couple of years back, there was one of the biggest breaches in the UC LA, the Los Angeles health system, which cost them millions of dollars in fine. And when that happened, the UC Office of the President of the university, basically came down with a heavy hand and said, all medical centers, all campuses are going to now follow a very strict cybersecurity program. And they've pushed down a lot of requirements on all of us at the various campuses. They've identified organizations that carry risk, like hospitals, like companies like mine, where we host sensitive data and we work with a lot of researchers and business units. So what this means is you really need an organization that understands all these things around cloud computing, compliance. In the US, there are strict laws, just like here, around protecting and managing health data. So HIPAA and things like that are big rules. But you really need all this capability to run an organization that can properly safeguard. And not a lot of these organizations have this capability, especially in an academic system, where you need collectively this expertise in one location to really meet the compliance requirement. So they came to us. So my group runs this platform called Sherlock. So UC Risk Services came to us, and they said, we've had a long-standing partnership with them. We've been doing work with them for about 4 or 5 years now. So they came and said, well, we would like to host this platform in this HIPAA-compliant environment. And HIPAA, just to give you a very quick background, HIPAA basically says there are two main aspects to it: the privacy rule and the security rule. So the privacy rule deals with making sure that you're dealing with patient information correctly, that you're not sharing it. And security rule deals with enforcing technical controls to make sure all your data is secure. So those are the regulations we had to follow. They wanted an on-premise infrastructure with us in our data center, so they knew where all their data sits. But they wanted the capability to expand in the cloud down the road. And then, obviously, they were dealing with large amounts of data here over time, not in the beginning, but they were also dealing with a lot of unstructured data. They were going to have video files, audio files, lots of documents. So they really wanted to go the big data Hadoop route here in terms of a technology solution. So based on all this context and this interaction, we kind of went ahead and started building some of this capability. So let's talk about platform technology and operations and what we did here. So Sherlock, which is the platform my group runs, really is a managed infrastructure as a service platform. So think of AWS or Azure as a cloud. A lot of these times, these cloud platforms are not enough when it comes to dealing with cybersecurity and meeting the compliance requirement. These vendors offer compliance at the basic level, and it comes to infrastructure, compute, and storage. But you have to build your services on top of those services to really meet the compliance requirements. And they call this model a model of shared responsibility. So that's really kind of where we excel. And then we build solutions on top of it. So the idea is we're giving an end-to-end solution to our customer so their compliance and their technology needs are met, and all they're focusing on is their science goal or their business goal. So that's what we've been doing. And over the last couple of years, we've launched a truly hybrid cloud. For the longest time, we had an on-premise capability, and then we added AWS, and we duplicated what we did on-premise in AWS to truly build a hybrid cloud that lets you be in either of those environments. And then we've also deployed this platform, a HIPAA-compliant big data platform in on-premise capability with a DR, disaster recovery and business continuity, being built in AWS. Again, a lot of kind of vendors and products here that some of you from the security background might know. But really, we use a suite of products when it comes to managing our security posture in terms of services that you need to manage accounts, run your vulnerability management program, your security, firewalls, and things like that. So a lot of investment and time goes in really running these services on top of cloud providers, whether it's AWS or Azure or whatnot. And really, those tools together help you meet this requirement, whether it's HIPAA, even with GDPR. GDPR actually points to a requirement that we follow in the US called the NIST 800-53, which is a very good starting point for how to manage a secure platform. This gets a little technical, but I just wanted to give you an idea of how we have always designed our platform. Our background comes in managing highly secure systems for the government that follows this requirement called FISMA, and that's been kind of our background in getting into the HIPAA and protected data space. But what this shows you is a lot of segmentation here. So you will see a lot of firewalls running across your dev, test, and production environments, as well as vertically between your presentation app and data server. So we have a lot of segmentation. The idea is that you want to keep the data as far as possible from your web servers and your app servers. And even if there's a breach, if a breach happens, they're going, the intruder has to go through a couple of different firewalls to really get to your data. So we try to create that segmentation and run all our management services that help manage this. For instance, there is no direct SSH access to our servers for any of the developers we work with on the customer side. They have to VPN, two-factor in, to get into the environment. And even for end users, we try to enforce very strong passwords, use of applications through two-factor and things like that. So, this has been our guiding principle. So when we started working with AWS, we went to them and we said, we want to duplicate this platform in your environment. So tell us what you offer out of the box, and then we'll apply these principles on top of it. So we took this platform into AWS and built this. So, as I was mentioning before, you've got the basic AWS capability at the bottom. Then we run a bunch of services on top of it from a compliance and security standpoint. And on top of that, the value we bring is really kind of helping build the end-to-end solution, whether it's a big data platform, whether it's a data management solution, whether it's data science. So really this whole stack is what we bring. And in the context of this project, we used Cloudera, which I hope there are no people from Hortonworks here, but that's the vendor the customers decided to choose, and so but they're all these technologies are built on some of the core open source platforms. So let's talk about the solution that was built. So obviously those who are in this space will sorry, it's a little hard to understand, but pretty standard architecture. They wanted to bring in data, they wanted to perform their ETL loads and get that in. They were very particular about exposure of sensitive data. They wanted that sensitive data to just stay in the production environment, control access, before it moved into test and dev environments for ETL purposes and for developers to build other things on it. They wanted to make sure it's de-identified and stuff like that. So a lot of capability had to be built, and then obviously exposing that, ingesting it into the Hadoop ecosystem and exposing it through a bunch of tools, BI tools. They started with Cognos, and now they're looking at Tableau. So really just building that whole stack there. But they were also interested in some direct access to Hadoop from different interfaces for more of the kind of command line and analytical type of folks who wanted that access. But like I said, there were some heavy requirements around de-identification. They really wanted to keep production data in prod. So we worked through some of those things, to iron out. And as I talk about some of the key takeaways, one of the challenges was just getting the stack and the Hadoop platform to work within a highly restricted environment like ours, where by default all firewalls are blocked, no ports are open. So we kind of had a lot of work to do there to get through some of that. I think the key message here, this shows how in my earlier slide, I had shown you an architecture we like to follow. And when we approach any of our customers and we work with someone, we try to take their requirements and try to fit it in our typical architecture. So you will see here that this looks very similar, a lot of segmentation between the environments, both vertically and horizontally. And then we've brought in the Hadoop clusters, the big data platform, to adapt into that kind of like a plug and play model. And as we are looking in AWS now, the great things about AWS is the maturity, or these cloud platforms, the maturity and the automation they offer. So when we move this to AWS, we could just write these things called cloud formation templates that let you program all this and just launch that script, and it creates everything for you. So I think as we move this towards AWS in a disaster recovery, business continuity capability, or even as a production instance in the future, I think it just makes things really simple. So what were some of the key design considerations? Obviously, we wanted a scalable platform. They wanted a scalable platform, grow as the data domains are added, as more data from campuses, from various medical centers was added, reduced time to value proposition. They were a big organization that did the old model, the relational databases, the data warehouses, your star schema and things like that. Really, they wanted to take a different approach. They wanted to get the product out in front of the end user soon. They wanted to leverage all the community around Hadoop, all the tools and libraries that are available. I interact with them, my team does, but every time I hear they're bringing in a new library to do something else. So they are continuously leveraging that. Again, they want to, future capability for machine learning, predictive analytics. They want to be able to bring those tools out that are built on top of these platforms. Again, the challenges around highly segmented, controlled architecture that we run, the kind of data they host. We talked about the data landing in production. So these were some of the things that went into how we design and how we operate with them. Those who come from the Hadoop background, they probably know more about this than me, leveraging the Hadoop ecosystem, all the tools that come in terms of data processing, searching capability, workflow scheduler. They do have some challenges. They're trying to build single sign-on systems so that they don't have to manage a lot of the accounts. The user base for this is going to be from those 15 organizations I was talking about, each of the UC campuses, the medical centers. So they are trying to leverage a single sign-on system that lets those users use their local accounts that they use on their campus, be able to log into this environment. So a lot of integration there going in terms of single sign-on, using Sentry, and being able to control access. And so there are some challenges there in terms of getting that to work. Again, just to show kind of conceptually, data coming in from all these sources, going into the Hadoop ecosystem and the tools working on top of it. But we've kind of built this. By moving that entire platform into our cloud, it inherits all the security that we've built. So that is really what this is showing. In terms of their approach from a data management, the data lake approach really is kind of what they are. We were at a couple of sessions where they mentioned this strategy, but they wanted a schema on read approach, something where they can get this data in front of the users quickly. They wanted to be able to adapt this schema in such a way that they can meet the reporting and analysis needs of various organizations. I think previously they had spent a lot of time building even the BI capability in their organization, but now they're looking to just kind of be the data experts and push that out to users who may have this capability and let them consume from this lake. But obviously, from what I see, there are, as issues come with quality and cleaning, There are some challenges there around high-quality data reporting that they are working through. A lot of this data is coming from enterprise vendors that collect data at these hospitals and med centers, and a lot of times, as data goes into their system and comes out, there is sometimes an issue. And there are a bunch of teams involved. So, we are more on the platform, the infrastructure, cybersecurity side. There is a completely different data team. There's a completely different Hadoop implementation partner. So a lot of teams are trying to work together to kind of push this project along and meet those timelines with an agile strategy. But considering the strict nature of the environment, we've had to work through some of the challenges there, and that's been some lot of learning experience for us. I just wanted to touch a little bit upon on how we are trying to duplicate and back this up in Amazon. So again, given the sensitive nature of this project and the data we host, as we were looking to copy the data into AWS into an S3 bucket for disaster recovery and backup purposes, we had to work through some of those challenges. Data is encrypted and sits in our environment on premise, but as it's moved, even though on the AWS side we can encrypt the storage, there were some concerns that the data itself is not encrypted. The storage device is encrypted. Amazon gives you an encrypted S3 storage, but the data itself was not encrypted. So there were some concerns by some of their auditors around how are we securing, even though in AWS we are moving this data into our secure cloud, which is again HIPAA compliant and meets all those security controls. So we worked through some of those challenges and now are in the process of testing and really moving this data using some of the features that Cloudera offers in terms of being able to copy. But the idea is once this is done, we're going to develop those templates that will help us spin up a big data Hadoop cluster in AWS if the primary site were to go down, and just bring that up, plug in the data, and make everything available in AWS. So hopefully that's kind of the end product out of this. So what they have now, finally, in terms of capability here is it's actually gone into production. They've rolled out a bunch of reports to their stakeholders, which are subject matter experts at these medical centers. They have a bunch of, I think they initially launched it to 50 targeted users. And again, they're reporting on monthly KPIs, performance measurements, and just a lot of different data drill down capabilities. I think they've done this all in Cognos, and then now they're bringing in Tableau, which is another BI product, to be a little more visually appealing and get it closer to the end user. So what did we learn as we went through this process of how does a big data platform work in a restricted, secure environment, cloud environment that runs both on-premise and cloud? What were some of the things we took away? So obviously we went through the whole challenge of operating this platform, the Hadoop platform, in a HIPAA-compliant, FISMA-compliant, secure cloud. Again, making it work in that segmented architecture, making it flow nicely, and all the pieces talking in something that's closed by default. So we kind of worked through some of that and have our hands around it now. Agile development, even for developers who were coming from an open environment into our environment, this was not easy. I mean, there is no easy way to just move code. They have a GitHub repository. They publish. That repository is hosted within our environment. It's not a public repository, but it has to be pushed into the repository. Then you log into your other environment and pull it down. So really, by design, by default, it adds a few steps in how this happens. But as we are learning, we are trying to make it more efficient and faster for not only this customer, but anybody we engage in the future. We talked about de-identified data. in non-production environments. So there's a lot of effort in masking and removing all the sensitive data before it goes into the other environments. Distributed teams, again, various teams working and so managing a 60 node cluster, being able to manage that system, take it down for patching purposes, for operations and maintenance purposes. There's a lot of coordination that goes down. Obviously, resources in this space, in big data, and obviously it's a very demanding skill set, and some of these things are also new to the University of California system. They're trying to train their own people, they're trying to hire, and you can imagine trying to hire those kind of people in the Bay Area would probably be impossible and unaffordable for a university system. So they have to train a lot of people on their own and try to come up to speed. One of the other challenges we have is in our secure environment, from a compliance perspective, we've got to be able to patch and manage the vulnerabilities on these systems. So you can imagine on Linux and Windows and all the systems we use, the number of patches and vulnerabilities that come out on a monthly basis. And the compliance requirement states that if any of these are rated high or critical, you have to patch them within a certain window. Now, coordinating that with so many teams, with getting your business stakeholders to agree to it and patching that whole thing, it's a big challenge for us. So we have to try to continuously improve that, work with them. Even these big data Hadoop vendors, they release their patches to address a vulnerability in their system, but the cycle for application upgrade is 6 to 8 months. Now, that's a big challenge from a compliance point of view because you can't take that long to catch up on your vulnerability. So these are some things we kind of try to work around, and it's a agreement between us and the business owner of how these things happen. And then I talked about implementing the SSO solution. So they're trying to make sure that they have something that works for all their users across these 15 locations, and also working through, given that there are 15 locations and users coming to access different reports and different data, that not everybody will be able to see everything. They are spending a lot of time getting fine-grained authorization going with Sentry, which I believe has some challenges around kind of what is allowed to be viewed from a column level security and things like that. So they're working through all of that. So that's really what I wanted to talk about and capture. I'll open it up for any questions, anything that you wanted me to spend more time talking about. I'm happy to share. Yes.
You mentioned actually that the traditional BI tools like SAP or Cognos or whatever, you said it's not actually suitable for them.
Right.
Do you actually find out a solution? What would be the best? Are there alternative solutions for that? Or how do you actually also, you get how is the performance actually when you actually do directly these tools? If you're not persisting it again into their another area, the same area where the reporting tool is sitting.
Sure. So the question is, I had in the lessons learned a comment around the fact that some of the standard BI tools don't necessarily work out of the box on these Hadoop platforms. So what did we learn from them, and did we make any changes? So from what I know, as those teams are working on them, they did have performance issues. When they started with Cognos and stuff, they spent a lot of time in optimizing queries, and there's another Cognos team that's really working. They're going to try Tableau now to see if that improves. I mean, I actually don't know this space very well in terms of what tools work. Really, I think it'll come down to making sure that you are exposing the right things out of the lake that are consumed by your BI tools, whether you choose Tableau or something else. I think they are limited in what they could do. I mean, they have to find some tools that work for most people, whether that's Cognos or Tableau. So I think they're going to try to stick to that. But in terms of going through a drastically other route, no, I don't think they have chosen anything else. They're just within the BI space. They're going to try to work with some of these, and probably work on the lake to make it as kind of accessible as possible in terms of being consumed through APIs and other tools. Yeah.
Especially for health data, it will be interesting to apply machine learning methods on it. So the infrastructure you showed us is more classical BI.
That's right.
What about TableFlow, Cafe, and other stuff that usually have file-based access on the data? Do you have these offerings for data sciences within your infrastructure, and how do you deal with the security thing with file-level access?
Right. So we don't have these offerings. We are really just a platform environment. But you're right. I think they are the customers who are the team that has brought on the big data experts. They are looking at all these tools in terms of what does the Hadoop ecosystem offer, machine learning, other things that they could build on top of this that will add the value and be able to work through some of those challenges. So I think their challenges, this is all new to them. They are, this is the first couple of years into it, so they are going through the growing pains of learning how to get their hands around the big data problem. How does this data live in a big data ecosystem? What tools do they have to run? So I think if we were having this conversation a couple of years from now, they would probably be more mature and using some of those libraries. So hopefully, I think by the time they are ready, those tools are more mature to kind of be deployed. Yes.
One more question. You mentioned multiple environments in the cloud. Do you also somehow synchronize the data between the different environments? And how do you do that individually?
Sure. So the question is, do we have multiple environments? Do we synchronize data? So in this particular case, yes, the Hadoop implementation team that they work with, they actually wrote the code that de-identifies the data, and then using, I think, some write option through Cloudera, they're able to push that data into the other environments. And so I think they de-identify first, they move the data, and then they perform ETL in the environments to ingest it. So that's how they work. We don't offer that service. I mean, there are products, and you would think we are in this business, we probably, but there are products that help you de-identify data, and I'm sure a lot of the customers would benefit from it. But in our case, because we secure our entire environment, and so we look at dev and test in the same way that we look at production environment. So it doesn't matter if you have sensitive data in dev and test. We hold it to the same standards, so we could support that. I think with our environment, the idea is you move everything into the cloud, whether it's on-premise or in a public cloud. We manage it, you connect to it, you use it. When you disconnect, you're done. Everything stays there. Yes?
How do you monitor or detect misuse of your environment?
So the question is, how do we monitor and detect misuse of our environment? So I'm sure my security officer, who's standing in the back, he could answer that question much better. But we have a lot of firewall and systems built around the border and inside the environment. So we run, for instance, intrusion detection systems where we capture alerts and logs, so that's just at the border. But as you're coming through the environment, all east-west traffic and north-south traffic in our environment is captured through these firewalls and pushed into a log management system where we watch the logs. For this particular project, we are pushing logs from the environment, from the systems, from their specific systems into another container where those logs are captured and exposed to their developers and admins to see for some of that. Again, they are building. We offer that project by project, so really what depends on the needs of the customer. We offer the security and kind of really securing the entire environment in terms of firewalls and intrusion protection and web application firewalls and things like that. And then what we do at a project level just depends on what they want. If they want us to write the logs to a system and expose it to them, we can do that.
Do you have a backup cloud, or it's all on AWS, or do you have another technology in case you want to?
So just one thing, if anybody's interested in finding out a little more, we have some pamphlets and information on our capability, and you can grab them. So our primary infrastructure is on-premise, but we've duplicated the entire stack in AWS. So if today somebody came to us and said they wanted to build a big data platform in AWS and they wanted it to be compliant, we can host them in AWS. Yeah. Yes.
And do you support high availability?
High availability. So the question is, do we support high availability? Yes. Yes, we could. I mean, again, it's a customer requirement. So, if they ask us to spec out something that needs to run between the two instances across the on-premise and cloud, we could do that. Or we could run HA configuration in one location, like the AWS or on-premise. So we could do whatever the customer wants. The fact that now we have AWS gives us two geographically different locations. Our AWS setup is in Oregon, and we are located in San Diego. So we have two locations to do whatever kind of HA the customer asks for. Great. Yes. That's right. That's right. Good question. So question is, we use, to capture all our logs, we used a SIM product. And so right now for this project, the logs don't go to that environment. The SIM product is used for our cloud operations. And the logs go to only to one environment. Another product that we have, I forget the name, but we've set up for these particular customers. But you're right. I mean, as we grow and expand this, do we want to pull this into more of an enterprise product, like a real SIM product, and be able to generate alerts and see? And I think that's something we will have to consider down the road. Yeah. Great. Thank you very much.